looking at today's lesson is very similar to what we did yesterday. There's only going to be one main change. Extraneous solutions. So it is possible for us to get solutions that don't work back in the original equation. One of the biggest identifiers is kind of having this set up here where we have a variable outside of the radical. Anytime we have a variable outside of the radical when we're solving, there's a good chance that there's going to be an extraneous solution. So we look at this setup here, x is equal to the square root of x plus 6. Our first main step is to get the radical by itself. Is it? Yeah, okay. Our second step was to put both sides to the nth power. In this case, it would be to the second. So on the left-hand side, we have x squared, which will simplify to x squared. On the right-hand side, we have the square root of x plus 6 squared. Well, the square root and square will, leaving us with x plus 6. So at this point here, we do have a quadratic because we have an x squared, yes? Anytime we have a quadratic, we've got to get everything on the same side and it equal to 0. Okay. So we can subtract x from both sides, yes? And then what would we do after that? We would subtract 6, yes? Is there anything that says we have to do it in 2 steps? Well, no. We normally do it in 2 steps so that we can keep track of everything easier. We get the correct signs. We don't combine things that shouldn't be. But I feel at this point, y'all have done this enough times that doing this all at once isn't too big of a stretch anymore. Because what we end up getting is x squared minus x minus 6. If you still want to do it in 2 steps, there's nothing wrong with that. If you want to do it in 1 step, that's perfectly fine as well. Any questions on how we got to x squared minus x minus 6? Well, now we need to solve this quadratic. We can solve this by, sure. Now at this point, we've gone over many different ways to solve quadratics. We have the quadratic formula, we can factor, or we can graph. And graphing and factoring work well if we have integer solutions, either fractions or whole numbers. Here we know it's not going to be a fraction because the term in front of x squared is 1. If it's going to work, it's going to be a whole number. So we can graph or factor this. If we factored this, 2 sets of parentheses equals 0. Well, we need to figure out what the signs are. Since the 6 is negative, our signs are opposite. Factors of x squared are x and x, because that's the only set of factors for x squared. Now the factors of 6 are 1 and 6 or 2 and 3. Which ones do we want? 2 and 3, and the 2 would be positive or negative? Positive. 3 would be negative. And if we check this here, x times negative 3 would be negative 3x. 2 times x is plus 2x, which would give us a negative x for our middle term. So these are the correct factors. We good with getting these here? We've done these a lot by this point. Well, since 2 things multiply together to equal 0, one of them must be 0, yes? So for x plus 2, it would be negative 2. For x minus 3, it would be positive 3. Seems so. Because we could set both of them equal to 0. minus 2, x is equal to negative 2. Plus 3, x is equal to 3. And that's all we have to do to find our solutions. But for these here, especially these here, we need to check them. We need to make sure that they actually work in the original equation. Any question before we go back to check? So negative 2 and 3. So if we check negative 2, we'll say negative 2 is equal to the square root of negative 2 plus 6. At this point, we really should have an indicator saying that this is not going to work, because this is saying that whatever is going to come out of the square root is going to be negative. We can't have a negative number come out of a radical. If we went on and finished checking this, negative 2 plus 6 is 4, and the square root of 4 is 2. Since we're just taking the square root, we don't need the plus or minus, because we only add the plus or minus if we take the square root of both sides, if we're applying that to both. So that tells us that negative 2 doesn't work. If we check 3, 3 is equal to 3 plus 6. 3 is equal to square root of 9. And the square root of 9 is 3. So 3 is our only solution for this one here. It is possible to get no solution. It just works out that both values don't actually work in the original problem. And checking those is helpful. Any questions on this here? Is this really any different than what we did yesterday? Not too much. I mean, we're now having quadratics and these higher degree functions coming in, but the overall steps in the process isn't anything different than what we did before. Let's go on and look at this one here. We'll look at this one and then we'll move on to kind of the other types where we have something that's quote unquote more involved. It'll just look different. Now looking at this here, is the radical by itself? Well, yes. So we can put both sides to the nth power. We can put both sides to the second power, because we're just using the nth power to simplify all the radicals out. On the left-hand side, we get x squared is equal to what? 20 minus x. Again, we have a quadratic, so it's good to get everything on the same side and get this thing equal to 0. So we can add x to both sides and subtract 20. If this is too much in one step, break it apart. Do it one at a time. Because when we add x, we'd have x squared plus x, and minusing the 20 would give us x squared plus x minus 20. Any questions on any of this here? We kind of like doing those two steps at once, a little less work. It takes up less space, same thing. Just not as much space taken up. So now we just need to solve this quadratic. Since the term in front of x squared, the number in front of x squared is 1, most likely if it does have solutions, they're going to be whole numbers. So we could graph it, and then the graphing calculator will tell us the solution pretty easily. Or we can factor. Since the 20 is negative, our signs are going to be opposite. Factors of x squared are x and x. And now the factors of 20 that we want would be 5 and 4. And which one would be positive? 5. because we want them to add together to be positive, and 5 plus -4 would give us a positive x. So that's the ones that we want. I have a feeling you all have already got what the solutions are. -5 and 4. We're using the opposite operations. Or if we step this out, it'd be x plus 5 is equal to 0, or x minus 4 is equal to 0 because of our zero product property. We need two things multiplied together to equal 0. One of them has to be 0. We can subtract 5 from both sides, telling us x is equal to -5. Here, adding 4 to both sides tells us x is equal to 4, and we get these two answers here. Now we need to check to make sure to see which ones, if both of them work, or if one of them's an extraneous solution, or both of them are. So we check -5. -5 is equal to the square root of 20 minus -5. Okay, most likely this isn't going to work because we can't have a negative come out of a square root or an even root. Now if we finish solving this, well, 20 minus -5 is going to be 25. The negative and negative make a positive. And the square root of 25 is 5. So -5 equals 5. Okay, that doesn't work. 4 is equal to the square root of 20 minus 4. Well, 20 minus 4 is 16. The square root of 16 is 4. -5 doesn't work, but 4 does. So our answer is 4. Questions on this here? Because I feel problems like this here, we've got the hang of these, yes? Not too complex, not too bad. Let's look at this one here. So this one only has a square root. We don't have any variables on the outside, but let's see here, because there is something interesting that does work. First step is to get the radical by itself, yes? So we would do what? Subtract 13 from both sides. Which would tell us that the square root of 5n is equal to what? -10, because 3 minus 13 would be -10, yes? What can we do next? We can square both sides, yes? Something a little funny about that. We'll come back to it. Is if I square both sides, square root of 5n squared is equals 100. And lastly, to solve for n, we would divide both sides by 5. N equals 20, yes? Now, there's not a variable on the outside, but this one here, it's going to be good to check it. Let's check it to make sure, because, I mean, we've been covering extraneous solutions today. Might as well check this one as well. If we check this one here, so 13 plus square root of 5 times 20 is equal to 3. Well, 5 times 20 is 100. Square root of 100 is 10. And 13 plus 10 is 23. Is 23 equal to 3? No. So is 20 a solution? No. Did we have any other solutions for this? No, so this here is a no solution. Okay. I'm going to go backwards. I'm going to back this up just a little bit to this step here. What did we say can never come out of an even root? Negative. We can't have the even root of a number and get a negative number, because there's no way that this works. So at this point here, we could have actually said that this isn't true, because there's no way we can take the square root of 100, because that's what that would have to be, and somehow get negative 10. Because here we're looking for what number times itself gives me 10. Yes? But we know that this cannot be negative, so there's no way that this can be negative. And that's kind of a key that gives this away. But even if I missed that, did it still come out that it didn't work? Well, yeah, we can plug it back in and check. So if we notice, hey, the radical is by itself and it's equal to a negative, an even root by itself equals a negative, this doesn't work, this is going to be no solution, we can move on. If we miss it, we blew right past it, okay, it didn't work, when we checked it, it told us that it didn't work. Does that make sense? Yes? Let's try this one. So what do we do first? Subtract 10. It tells us that the square root of what can we do next? We can, yes? But can a radical equal a negative? So is this going to have a solution? This is going to be no solution, because we can square it if we wanted to, which will just tell us that 3m is equal to 81. Divide by 3, and we would get that m is 27. 3 times 27 plus 10. And again, for this to work, whatever comes out of that radical would have to be negative. We can't have that happen. It's just telling us that the square root of 81 plus 10 is 1, which would be 9 plus 10. 19 does not equal 1. It just doesn't work. Questions on this here? Not too bad. These are the cases where we do need to make sure to check, and it doesn't have a variable outside of the radical, so we have to be careful with these. On the test, I will definitely be saying check for extraneous solutions. I'm not most likely going to throw one like this on here because, again, I don't like no solutions on the test. Because I feel like that's more of a trick than anything. I'll put those on the review. I won't put them on the test. Let's look at this one here. This one's different because we have a variable and a number, yes? And with all of these here, again, we want to make sure the radical is by itself, or we can even them out. Is the radical by itself? So what was our next step? Put both sides to the nth power, yes? So we're going to put both sides to the second power. Now it might be very tempting for our p plus 1 squared to rewrite it as p squared plus 1 squared, but it's not. Because really what we're saying here is that we have p plus 1 times p plus 1 is being multiplied by itself. So we're going to have to use the distributive property to work this out. Now, as not nice as that looks, the other side looks a little bit nicer. Because the square root of 7p plus 15 squared, well, the square root and square will cancel each other out, telling us that we just have 7p plus 15. So even though this looked like it would make it a lot harder, it's just we're having to multiply p plus 1 by itself and then solve a quadratic. Any questions on this here? Now if we do this multiplication, p times p is p squared. P times 1 is plus p. 1 times p is going to be plus p. And 1 times 1 is going to be plus 1. Now we did get a quadratic. Now at this point here, we'll need to go on and combine like terms. So we can say, and we were going to scroll, that we have p squared plus 2p plus 1 is equal to 7p plus 15. Let's get everything on the same side. So we would subtract 7p from both sides. And we can also subtract the 15. And if we do this, we'll get p squared minus 5p minus 14 is equal to 0. And again, at this point, we can graph this. We can graph p squared minus 5p minus 14 and see what we would get. But if I graphed it, I wouldn't actually put p in. We would put in x. It's just a variable. Doesn't matter what we call it. And it would solve it for us there. We can also factor. And if we factor this, well, 14 is negative, so our signs are opposite. Factors of p squared are p and the factors of 14 that we would want are 7 and 2. 7 would be negative, 2 is positive because we have a minus 5p, because negative 7 plus 2 would give us negative 5. And we could solve it out saying p plus 2 is equal to 0, and p minus 7 is 0, because any two things multiplied together to equal 0 means one of them has to be 0. Subtract 2 from both sides, telling us p is equal to negative 2. Here we can add 7 to both sides, telling us p is equal to 7. Most likely, which one do we think won't work? Probably the negative 2 is not going to work, but it's still good to check and make sure. Is everybody good to move on to check? Yes? Okay. Make sure I'm not losing anybody. Negative 2 comma 7. So here, negative 2 plus 1 is equal to the square root of 7 times negative 2 plus 15. Well, the left-hand side kind of gives that away. Negative 2 plus 1 is negative 1. Should be negative 14 plus 15, which is telling us square root, or negative 1 is equal to the square root of 1. Negative 1 is equal to 1. Doesn't work. For 7, 7 plus 1 is equal to the square root of 7 times 7 plus 15. 7 plus 1 is 8. Seven times 7 is 49 plus 15. That'll be square root of 64. 8 is equal to 8. Yeah. You don't have to do this by hand. Really, at this point here, you could have typed it in. You can't type the whole thing in because of the equal sign. I really hope at this point you wouldn't have to type in 7 plus 1. But we could do that side and then type in the square root of 7 times 7 plus 15. You want to make sure to put the parentheses around what you're typing in, just in case it's negative or we're squaring a negative. And the calculator will tell you that that's 8, 8 equals 8, we're good. And on the test, if you're told to check it, you just need this and that. You don't need all the steps in between. Because just doing those two parts lets me know, okay, you actually did check it. And that's an easy point to 2 points, especially going here, okay, that doesn't work here, that does. You got your points for checking. Any other questions on this here? Any other questions on ones like this? These aren't that bad, are they? Go on and look at the rest of them that we have, because if there's one that y'all want to look at, we can look at it. If not, I'll go on and let y'all use the rest of the time to work on the assignment attached to this. Okay. So your homework is on page 269, 45, 46, and 49 through 57. Okay, I'm going to include this in the video. So the first two problems are from these four here, because I think it's 46 and one other. Determine which solution, if any, is an extraneous solution. So the correct answer for this are the ones that don't work. Does that make sense? So the answer is the numbers that you're putting down, because for 45, it says x is equal to 5 and 1. So you're going to check to see which ones work and which ones don't. If one of these doesn't work, then that's the answer for it. Yes? If it turns out for this problem both 5 and 1 work, then it's no solution. Like, none of them work. None of them don't work. Because you're listing only the ones that don't work, not the ones that do. Because we want the extraneous solutions. So for the problems 45 through 48, it's not wanting the ones that work, it's wanting the ones that don't work. So I wanted to point that out. For 45 and 46, you're just plugging those numbers in. If they work, okay, that's fine. That's not the one we want. We want the ones that don't. So for those there, 45 and 46, you're seeing which of those two numbers that they give you don't work.